Welcome friends. Today we will learn about how to perform one sample and two sample jet test for proportions in SPSS. This is something very interesting because SPSS does not support jet test for proportions to be performed. But there are other ways and means, some auxiliary way in which we can perform jet test for proportions in SPSS. Jet test for proportions are very useful, especially when you are dealing with count data. This is a part of all basic courses in test of significance, where the initial test and the test with which we start in most cases are jet test for proportion, one sample and two samples. So here we are going to do this jet test for proportion in SPSS. Okay, let us first have a look at what is jet test for proportions and how it is used. Okay, first we have jet test for single proportion. Here we are to check whether the population proportion is equal to a particular specified value P naught. As you can see, the null hypothesis is capital P, that is the population proportion, is equal to P naught. There are some assumptions of the test that independent Bernoulli trials are repeated a number of times. That means you are checking out with each and every individual whether they have a particular habit or not. If they have a particular habit, then we mark them as presence of the habit, that is 1, otherwise they are 0. So ultimately, when you end up surveying a large number of people, large number means more than 30 number of people, then some of those people will have that particular attribute. So accordingly, suppose we have 12 people having the attribute in a sample of 35, then the sample proportion is 12 by 35, as simple as that. Based on that, you are to check whether a particular specified value of the proportion is attained, like P naught say. There are alternative hypotheses, as you know, this is a two-tailed alternative hypothesis, that is P naught equal to P naught. And these are specific alternative hypotheses or one-tailed alternative hypotheses, which are actually opposing the null hypothesis. This is proportion is greater than the specified value P naught, and this is proportion is less than the specified value P naught. So these are the proportions which are to be tested. So these are alternative hypotheses. Now we go to the test statistic, and the test statistic. This is the test statistic where P represents, small p represents the sample proportion, and P naught represents the specified value which we want to test, and under root P naught Q naught by n. So n is the sample size. Now this entire thing follows normal distribution with mean 0 and variance 1, and accordingly we can test whether the null hypothesis be accepted because the table value at 5% level of significance of Z is 1.96. So in order to reject the null hypothesis, the value of the test statistic should be greater than 1.96. So often we take the modulus of Z so that the negative content of, in case there is a negative value of the test statistic, it gets overlooked, or it accordingly the comparison can be done. So this is all about Z test for single proportion. Let us take up an example to understand it better. So a sample of 430 college students were questioned, do you smoke regularly? So this was a question. Now sample size is quite big, as you can see, 430. Out of these students, 113 of them admitted that they do smoke. So 113 out of 430. So 113 divided by 430, that is my sample proportion. Test if the population proportion of smokers differs significantly from 0.3. So this is the test for population proportion of smokers differ significantly from 0.3. So that is what we want to test. Now we come up here, we make a table like this, and so that our computation in SPSS becomes easier. A sample of, so I have written the question once again, and here we have two types of people in this sample of 430. Some are smokers and some are non-smokers. So attribute under consideration is smoking. So we have counted how many number of people are smokers, 113. So 113 we have written. And this is non-smokers, remaining are non-smokers. So 430 minus 113, that has given me 317. And since we are checking whether the number of smokers is 30%, so smoker hypothetical proportion is 30%, 0.3, and non-smoker is 0.7. So these are the values that we have for hypothetical proportion. These are the two groups of values that we have. Hypothetical. Now let us proceed and let us go to SPSS and try to friends, we are in SPSS now. So let us now prepare our variable view so that we can perform Z test for single proportion in SPSS. So we go to variable view of the data set. This is a new file that we have opened. So we go to the variable view of the data set, and then we create two variables. One we give the name, say type, means this is a smoking type, and another we give count. Count means the number of people who are smokers and non-smokers. This will come here. Okay. So count, this is also numeric. Anyways, so here what we do, type we have, we'll actually code the data as smokers and non-smokers. So here we go, we make it 0. And since it will be coded as smokers and non-smokers, so we write 1 here. And then we come here level, we may write smoking habit of the respondent, smoking habit, and values we go, we give 1 to smoker, add, and then we give 2 to non-smoker. Then we give it. So 1 and 2, then we click on OK. So we click on OK, then we get this. When we come back here, we find that we have defined variables. This. So what we do, we go on here, we type smoker, and we go on here, click this, and then we get 2 options. Out of this, which we pick up non-smoker. Once we go this, we go to count data, and if you go to your PowerPoint, you will find that the count is smoker is 113 and non-smoker is 317. So here we come 113 and this is 317. Now you see we are getting 0.00, which we don't want. So what we do is that we make here and make it 0. Once we make it 0, we get it like this. And also you see these are 3-digit numbers. So we may come here and make it 3 instead of keeping it 8. So this is a good practice. So now we are here. But unfortunately, under analysis or under anywhere we generally find all different types of tests, there is no compare proportion type of test is not there. That means we cannot do it in this way directly. So what we do is that we go to analyze, we go to non-parametric tests, and we go to legacy dialogues, and then we have chi-square. So Z is not there available anywhere. Z test for proportion in SPSS. But we can perform chi-square test, and from there we can shift to Z test. I will tell you how. So first perform the chi-square test. So what we do is that we go click on chi-square test, and we come here for this. But before we do this, we need to perform, before we perform the chi-square test, we need to perform one small information we need to pass on to SPSS. So let us close this window for the time being. What we do is that we go to data, and last option you see there is weight cases. That means weight means here relative importance. So weight cases. So we come to weight cases, and then we weight cases by, and then count data, that is the frequency. So there is the count. So this we do exercise we have to do. So we bring it here, count data, and then we click on OK. So weight cases by count. So data is weighted. Now we go to analyze. Now we go to non-parametric. Now we go to legacy dialogues, and now we go to chi-square. That means we have to come to chi-square. But before that, we have to do this small exercise and inform SPSS that okay, we are already giving you some data values with the help of which you can do the weighting or relative importance of the two variables or two groups like smoker and non-smoker. So that information we have to pass. Here, what is the test variable? Test variable is smoking habit. Okay, and once we give this all categories equal, no, the categories are all different. So values. So first here is your smoker. Smoker is 30%. So 30% is nothing but 0.3. So you type 0.3 and type add. And second proportion, that is this is 70%. So what you do is you write 0.7 here and you click on add. So 30% and 70%. This actually matches this sample proportions, hypothetical proportions that you have computed earlier. Okay, we come back to SPSS. So this is all done. Just you click on OK. And once you click on OK, you get here chi-square test statistic values. So chi-square test statistic values. So these will help us to reach to the value of Z test. Now we come back here. We actually copy this table which you got here, this test statistic table, and then with the help of this table we can move to Z. So this table is copied here. You see chi-square value is this much and the asymptotic significance is this. Now you see our null hypothesis is obviously 0.3, but this line will tell you what is the alternative hypothesis. It tells you the test if the population proportion of smokers significantly differ from 0.3, significantly differs. That means it may be in the higher side, it may be in the lower side also. We are not so much concerned with that. That means our alternative hypothesis is P not equal to 0.3. P not equal to 0.3. That is our alternative hypothesis. So we take the alternative hypothesis as a two-tailed alternative hypothesis. This you can understand from the language of the question or the problem of the research. So accordingly we come down here, and what we do is that we first take the square root of Z, square root of chi-square value. There is a relationship between Z and chi-square, that square of Z, that is Z square equal to chi-square. So if you want the value of Z, you just take the square root of chi-square. So we take the square root of this value 2.835 and this is 1.6837. So that is the calculated value of Z. And this significance, this asymptotic significance, that is the p-value of the test. Now if your null hypothesis is one-sided null hypothesis, that if I tell that test whether the proportion of smokers is more than 30% or proportion of the smokers are less than 30%, then you will take half of the asymptotic significance. But here, since the alternative hypothesis is two-tailed, so we take exactly that asymptotic significance as our p-value. Now you know that for the null hypothesis to be accepted, the p-value should be greater than 0.05. And if the p-value is less than 0.05, then we reject the null hypothesis. Here you see the value of p is less than, more than 0.05. So what we do is that we accept the null hypothesis and we draw the conclusion that the proportion of smokers is not significantly different from 30% or 0.3. So that is how we draw the conclusion for and perform Z test for proportion one sample. Next we go to Z test for equality of two proportions. Okay. Now we go for Z test for equality of two proportions. That means we have two samples and we count the proportion of a particular attribute in the two samples, and based on that we conclude or we draw the hypothesis, test the hypothesis that proportion, first proportion is equal to second proportion, P1 equal to P2. Alternative hypothesis H1 P1 not equal to P2, or H1 is P1 greater than P2, or H1 is P1 less than P2. So this is the test statistic. So when the test statistic is this, so accordingly we have P1 equal to x1 by n1, P2 equal to x2 by n2, and the proportion, this is the pooled proportion, that is n1 P1 plus n2 P2 divided by n1 plus n2. So this is the first sample proportion, this is the second sample proportion, this is the pooled proportion, and Q cap is 1 minus P cap. So entire things we replace in this formula, and accordingly we get the value of the test statistic. And this follows actually standard normal distribution with mean 0 and variance 1, and so the value of Z less than 1.96, which is the 5% value of Z, leads to the conclusion or rejection of the null hypothesis. But let us see how things are done in SPSS. But before we go to SPSS, let us take up a question like this. In a city, say let us call it city A, there are 160 smokers in a sample of size 500. In another city, so let us call it city B, there were 30 smokers in a batch of 100. Thus, each of them have smokers in equal proportion. So that is very interesting. The smokers are there in equal proportion in the two cities. So before we go to SPSS, we actually put the information in a tabular form. City A smoker is 160, as you can see here. City A non-smoker is 500 because that is the sample size, minus 160, that is 340 you get here. And in city B, the smokers are 30, so this is 30, and non-smokers are 100 minus 30 equal to 70. So this is how we get the smoker, non-smoker in the different cities, city A, city B. This is the way in which we have got this. Now we take this information in SPSS and let us try to conclude. So try to perform the Z test. So we come back to SPSS and then what we do is that smoker, non-smoker, that is required also, but well, I try to insert a new variable. So insert variable, I click and a new variable gets created. So we go to variable view now. We write it, say I give it a name city. So decimal I make 0. This one I'll make 1 and I'll try to code it. I'll go here. I'll code it as 1. I'll give city A. Add, and then I give 2 city B. Add, so city A, city B that I have got, and then I click OK. So this okay, fine. Count data, okay. Type we have smoking habit, smoker, non-smoker. So we come here. What we do is that we click here and then we pick up city A. Here also we click and get city A. Here we get city B. Here also we click and get city B. So these are the way I want to erase the data as in case of this. As in case of this. Well, we come back here. And then we have smoker here. And we have non-smoker too. So this my text is complete like that. And now let us look at these values. What are the values in SPSS? 160, 340, 30, 70. 160, 340, 30, 70. So I make it 160, 340, 30, and 70. So we have this data set. Now we go first to data, we go to weight cases, and then already things are weighted by count. So this is already done as I have done it earlier, so it has remained because I have made a correction in the same database to reach this point. And we click OK. So weight by count, it is already weighted. Close this window. Okay. Now what we do is that we go to not chi-square. We go to, we use chi-square but not in directly in the as in the previous view. We go to descriptive statistics. In descriptive statistics there is an option called cross steps. So we click on cross steps. So when I click on cross steps, this window appears before us. In the window, along the rows we take city, and along the columns we take smoking habits. And that is all. Count is already, it has been weighted, so it will automatically take the count. Now we go to statistics and now we click in chi-square. So this is the things that we do, and then we go to continue. Once we go to continue, these values are there. We click on OK. So as soon as we click OK, we get the chi-square test value. You see, we get the table also. City A, city B classified by smoker, non-smoker. So this is a two-way table that has been created. Okay. Now we get the chi-square table and we get the asymptotic significance also 0.695. We bring this table so that we can understand it properly. We bring it in PowerPoint. We come here, the same table I have just copied and pasted here, and how to do the computation. And as you know that Z value and chi-square value, we take the square root of the chi-square value to get the Z value. So chi-square value is 0.154. We take the square root of that and we get equal to 0.392. So 0.392, that is the value of Z. And asymptotic significance, since this is a two-tailed test. How do you understand two-tailed test? From the language of the question. Does each of them have smokers in equal proportion? So null hypothesis is proportion of smokers is same, that is P1 is equal to P2. Alternative hypothesis will come out of the question of the problem, that is here you want to check whether they are in equal proportion. The alternative hypothesis is that they are not equal, and so the asymptotic value, this is same as the P value. If you take half of this asymptotic value, then we'll get that is the case when we are dealing with one-sided alternative hypothesis. But since this is two-sided alternative hypothesis, so the same value will be carried forward here. So what will be the decision based on the P value? We will decide accordingly. That is, if the P value is less than 0.05, then we will reject the null hypothesis. But in this case, the P value is greater than 0.05. That means we accept the null hypothesis, and then we draw the conclusion that the proportion of smokers in the two cities, does not differ significantly. The proportion of smokers in the two cities does not differ significantly. So that is how we conclude for this test. Thank you for watching this video.